Why light never slows down. What if I told you that light never slows down, no matter how fast you chase it? That time itself bends because of this single fact, and that black holes exist because photons cannot slow down. Today, we're going to understand time, light, and black holes not with equations, but with geometry, logic, and imagination. What is time really? We usually think of time as something that flows, like a river moving forward. But in physics, time is not a thing. Time is a measurement. Time is what clocks measure. A clock is anything that repeats, a heartbeat, a swinging pendulum, or an atom vibrating. Time is simply a count of repeated events. The most perfect clock imaginable uses light. Imagine two mirrors, one at the bottom, one at the top. A single photon bounces between them. Each bounce is one tick of time. This is called a light clock. Let's give this clock real numbers. Distance between mirrors, 1 meter. Speed of light, 300 million meters per second. Light travels 2 meters per tick. So one tick takes about 6.7 nanoseconds. That is time, defined by light. Now comes the strange part. Let the entire clock move sideways while the photon is bouncing. From the clock's own perspective, the photon still goes straight up and down. But from a stationary observer, the photon travels diagonally. Why? Because while light moves upward, the mirrors move sideways. Light speed cannot change. So if the photon travels a longer path, it must take more time. This is time dilation. Time doesn't slow inside the clock. The geometry of space-time forces different observers to measure different durations. This is not a mechanical effect. All clocks, atomic, biological, digital, slow down together. Now the deepest question. Why is the speed of light the same for all observers? Because light is massless. A massless particle has no rest frame. It cannot slow down. It cannot stop. It can only move at one speed, c. Light doesn't travel through space-time. It defines space-time. For a photon, time does not pass. From emission to absorption, the elapsed proper time is 0. This is why light always moves at light speed. Experiencing time requires mass. Now we reach black holes. Gravity does not pull light like a rope. Gravity tilts space-time. Near a black hole, space-time is curved so strongly that all possible future paths point inward. At the ever-horizon, even outward-moving light cannot escape, not because it slows, but because escape is no longer a direction. Light cannot slow down. Time bends to protect light speed. Gravity curves space-time. Black holes form when space-time tilts so much that light itself cannot escape. This is not magic, it is geometry. The universe does not slow light. It bends time and space instead, and in doing so, it creates the deepest structures in reality. If you understood even half of this, you are already thinking like a physicist.